So the Nirenberg and Matthaei experiment is the experiment responsible for translating the first codons in the genetic code through the understanding that certain bases code for certain amino acids. In order to do this experiment, Nirenberg and Matthaei needed a cell-free system so that they could add whatever RNA they wanted to the system without interference. They chose to use cytoplasm removed from an E. coli. Taking their E. coli cytoplasm, Nirenberg and Matthaei then filled 20 test tubes with the cytoplasm, an RNA strand composed purely of uracil, known as poly-U, and various amino acids. However, one of these test tubes was tagged radioactively with carbon-14 so that it could later be identified. This experiment was repeated numerous times as the mixtures were filtered and precipitated until finally the radioactively tagged amino acid appeared in the precipitated mixture. When this finally happened, they were able to determine that UUU was the codon for phenylalanine. From this, the experimenters were able to determine that a repeated chain of uracil bases led to a repeated chain of phenylalanine amino acids. Repeating the same steps using other amino acids, they were finally able to determine that 3 adenines codes for lysine and that 3 cytosines codes for proline. So now that we've talked about the Nirenberg and Matthaei experiments, we can finally talk about the Nirenberg and Leder experiments. The Nirenberg and Leder experiment served as kind of a follow-up to Nirenberg's work with Matthaei, except this time, rather than just decode the first codons of the genetic code, they were setting out to finally decode the rest of kind of the more ambiguous codons in the genetic code, or the more complex ones that didn't necessarily consist of triplets of repeating bases. So since the codons that they wanted to look at now didn't consist of repeating bases, Nirenberg and Leder couldn't use the same kind of long repeating RNA strand like a poly-U or a poly-A that they used in the Nirenberg and Matthaei experiment. So instead, they had to use very short RNA strands consisting of just 3 nucleotides in order to be able to be sure that they were deducing the right codon, since these things attach randomly along the RNA strand. So to deal with these shorter sequences, Nirenberg and Leder implemented a special millipore filter that would allow unbound tRNA to fall through, while tRNA ribosomes that were bound with an amino acid would get stuck. Using the same kind of radioactive tagging and subsequent identification of amino acids as in the Nirenberg and Matthaei experiments, Nirenberg and Leder were able to one by one further identify the remainder of the genetic code, thus deciphering it as we know it today.